Hi class, this is Miss Cook. In this video we're going to work on solving a side-side-side triangle using the law of cosines. So we have here that the triangle we're looking at has side A of 6 units, side B of 9 units, and side C with 4 units. Alright, so we are going to have to use the law of cosines, just like previously in this section and in 4.2. These are oblique triangles, so we unfortunately can't use our right angle trigonometry. Alright, but we can use a similar example, or a similar trick rather, to what we did when we solved our SAS triangle in the previous video, and rewrite the law of cosines to solve for cosine of any of those three angles. All right. I am going to use angle A and angle B. You can use whichever two angles and solve for whichever two angles using the law of cosines you want. All right, so the goal is going to be, we're going to solve for two of my angles using the law of cosines, and then we can find the third one from there pretty easily. All right, so I usually use A and B again, so we are going to start with the law of cosines for side A, because on the right-hand side of that equation we have angle A, and that's what I want to find first. So A squared equals B squared plus C squared minus 2B times C times cosine of angle A. Alright, so now, just like with the previous video, we can do some clever rewriting and solve this equation of the law of cosines for cosine of A. So I'm going to subtract A squared from both sides, and I'm going to add 2BC cosine A to both sides. And what that's going to do is it's going to switch the places of those two terms, and now I have cosine of A on the left-hand side rather, and I have A squared on the left-hand side. Alright, so now I need to just get cosine A by itself, so just like previously I'm going to divide both sides by 2 times B times C. Okay, so what this tells me is that cosine of A equals B squared plus C squared minus A squared divided by 2 times B times C. All right, and on the right hand side those are all sides. Okay, so now I'm at a place where I can just plug in A, B, and C. So cosine of A equals 9 squared plus 4 squared minus 6 squared, and then divided by 2 times 9 times 4. And I'm going to put this all at once into my calculator. That's why I'm not like sitting here and trying to square those first and rewrite it with these numbers squared. I'm just going to put it just like this in my calculator. And when I do that, I get that cosine of A equals 0.847, and then 2 repeating. So just like with the last video, I'm going to use an inverse cosine function of that decimal there, so 0.8472 repeating, to get my angle A. So it's going to give me angle A in degrees. And when I do that, I get that angle A is approximately 32.1 degrees. All right. So now we can do the same trick with the law of cosines, but for any of my other two angles. I'm going to go with angle B, but you can use angle C if you wanted to. I'm not going to solve again. I'm just going to essentially use what I have here for cosine of A to write cosine of B. All right, so cosine of B is going to be A squared plus c squared minus b squared divided by 2ac. All right, so then cosine b, I'm just going to fill in all of that information. So 6 squared, let me write that a little neater. 6 squared minus 4 squared plus 4 squared rather minus 9 squared divided by 2 times 6 and times 4. And I get negative 0.6041 repeating. All right, so notice I got a negative answer. Well, that is okay because this is an oblique triangle, so I'm going to allow for negative answers. And cosine will be negative in quadrant 2. So this just tells me that my cosine is going to be in quadrant 2, so there's going to be I'm going to have an obtuse angle. All right, so when I still use my inverse cosine function, so cosine inverse of negative 0.60416 repeating, I get that angle B is equal to 127.2 degrees. All right, so now all that's left is to find angle C. So we find angle C just like we find any angle when we have the two other angles. I'm going to take C equals 180 minus angle A, which we said was 32.1, and minus angle B, which we said was 127.2 degrees. And I get 20.7, so C, or yeah, 20.7. So I get that angle C is 20.7 degrees, and I have my final triangle here.